Question 27, find the product Z1, Z2, and the quotient C1 over Z2 in two ways, using polar form and using the standard form for Z1 and Z2. We're going to use the polar form, folks. I'm guessing, I don't think there's a part B of that I want you to ignore, and here's why. The standard form would be to take you back to Algebra 2. Okay, now I am pretty confident that you can multiply binomials. I'm pretty confident that maybe I'm less confident in your whole division skills, only because you would forget that you had to multiply top and bottom by the conjugate of the denominator. That may be something that that's a skill maybe that you would have to be reminded of. I am more interested in you being able to do this part right here. Use the polar form. So we've got 3 minus 2i. What do we do with those? What form do we need them in order to multiply them? We need them both in polar form. So the most work you're going to have in this problem is changing them to polar form. You've got 3 and a minus 2i. And then you've got 1 plus I. Okay, so how do we know those are the locations of 3 minus 2i? You treat it just like a coordinate. The first number, the real number, is your movement along the real axis, and the second one is the movement along the imaginary axis, or the vertical. It's just like a coordinate.
So it's just like 3, -2, and 1.
Correct. That's all we have here are those two. Now, in order to do the rest of it, what do we need? We need the radius, thank you very much. So we need the radius of that one right there. So if we've got a side length of 3 and a side length of 2, that's probably going to be radical 9 plus 4. Okay. Does that make sense now? So it's going to be the square root of 13, right? So how am I going to find the angle measurement inside there? I'm going to invert the tangent, 2 over 3. Now, when you invert the tangent of 2 over 3, not going to be a nice number? Make sure your calculator's in the right mode, so if you want to be in degree world, change it to degree. Invert the tangent of 2/3. You get 33.7 degrees. Don't use 33.7. You probably need to do something with that. You're in quadrant 4 according to the picture. 360 minus, thank you so much. You've got to use that to come backwards here because you're trying to find this angle all the way around. So the first one that I'm dealing with is radical 13, cosine. So does anybody know what 360 take away 33.7 is? 326.3. Is that what? Yeah, that's right. Good job. No, go ahead. Yep. Okay, they've got it in radians. Don't worry about it. Okay. Okay, now that's our first one. We need to find our second one. So think about that blue one that we've got drawn there. It's got side lengths, and if I would zoom in, you'd have side lengths of 1 and 1. So that means that the radius is going to be radical 2. And then what's the angle measurement inside here? 45. Now, this particular question is going to be asking me to multiply these and divide them. Multiply and divide. So, when you multiply, what do you do with the radii? You multiply them together. What's radical 13 times radical 2? Radical 26. Good job. What do we do with the 326.3 and the 45? You add. Good call. So 326.3 plus 45. 371.3. Okay, then you would have to divide those to do the other part of that question. Now listen to me. Hey, my time. Sit. Listen. Don't move. Listen. This particular question forces you to change them first into the trig form and then multiply them together. That's a lot for one question. I would probably, on a quiz or test, give them to you in polar form already and ask you to multiply them together, and then in a separate question ask you to change one into its polar form. But I don't think I'd put both in the same question. Okay? Too much stuff. Hey, you do the same. Enjoy it.